Artificial intelligence, AI, has come a long way since its beginning, and one of the most significant contributors to its progression has been Google's Deepmind. Established in 2010, Deepmind is an AI research lab that has made groundbreaking strides within the field of self-learning, moreover known as reinforcement learning. By harnessing the power of neural networks, big data, and advanced algorithms, Deepmind has pushed the boundaries of what AI can accomplish. Understanding self-learning in AI. Self-learning or reinforcement learning is an AI training method where an agent learns to make decisions by interacting with its environment. Deepmind's work in this area has been nothing short of revolutionary. The rise of deep reinforcement learning, Deepmind's biggest achievement, came in 2013 when they developed a model called DeepQ Network, DQN. This model was the first to combine deep learning with reinforcement learning, enabling AI agents to learn and excel at classic video games like Atari 2600. Deep reinforcement learning, DRL, is a type of machine learning that permits AI frameworks to memorize to act ideally in an environment by trial and error. DRL systems are trained on a dataset of experiences, which are basically sequences of actions and rewards. The framework learns to relate certain actions with certain rewards, and over time, it becomes better at taking actions that lead to the desired result. Deepmind is a research company that has been at the cutting edge of DRL research. DQN's ability to outperform human players in these games demonstrated the potential of deep reinforcement learning. Since at that point, Deepmind has created a number of other DRL frameworks that have accomplished noteworthy results in a variety of domains, counting Atari games. Deepmind's DQN, DeepQ Network, calculation was able to memorize to play Atari diversions at a superhuman level. Protein folding. Deepmind's AlphaFold program was able to foresee the structure of proteins with phenomenal precision. AlphaGo, defeating human champions. In 2016, Deepmind's AlphaGo made history by defeating the world winner Go player Lee Sedol in a 5-game match. Go, an ancient Chinese board game, is known for its unimaginable complexity, with more possible board positions than there are atoms in the universe. AlphaGo's triumph checked a noteworthy turning point in AI, illustrating how self-learning algorithms can handle immensely complex issues. AlphaGo's triumph over human champions has had a number of implications for the field of artificial intelligence. It has appeared that AI frameworks can presently compete with people at the most elevated levels of a complex game. It has moreover appeared that AI frameworks can learn to play games by trial and error and to improve their play over time. AlphaGo's victory has moreover raised a number of moral concerns. A few individuals have contended that AI frameworks that are able to overcome human champions seem to pose a risk to humankind. Others have contended that AI frameworks ought not to be utilized to play games that are traditionally played by people, as this might lead to the erosion of human culture. In spite of these concerns, AlphaGo's triumph over human champions could be a major breakthrough within the improvement of artificial intelligence. It has appeared that AI framework can presently compete with humans at the most noteworthy levels of a complex game. This can be a significant achievement, and it proposes that AI frameworks have the potential to outperform human capabilities in a number of other areas as well. ALPHAZERO generalizing to multiple games. Building upon the success of AlphaGo, Deepmind introduced ALPHAZERO in 2017. Not at all like its predecessor, ALPHAZERO was not restricted to just one game. It seemed to learn and achieve superhuman performance in numerous board games, including chess and shogai. What was remarkable was that ALPHAZERO learned these games with no prior human knowledge, depending exclusively on the rules of the games and self-play to improve. This ability to generalize over spaces showcased the gigantic potential of self-learning AI systems. ALPHAZERO's ability to generalize to numerous games could be a significant accomplishment. It appears that AI systems can learn to play modern games without being explicitly programmed. This has the potential to revolutionize the way we play games because it seems to permit us to make AI opponents that are able to play any game at a superhuman level. Sim-to-real transfer. One of the significant challenges in reinforcement learning is transferring knowledge from simulated environments to the real world. Deepmind handled this issue by introducing advancements in sim-to-real transfer. This breakthrough permitted AI operators to memorize complex tasks in virtual simulations and offer that transfer that learning to real-world scenarios. This method has immense implications for robotics, autonomous vehicles, and other real-world applications of AI. Sim-to-real transfer features a number of advantages over conventional methods of training robots. To begin with, it is much cheaper to train a robot in simulation than it is to train it within the real world. Second, it is much more secure to train a robot in simulation, as there's no hazard of harm to the robot or to the people. Third, sim-to-real transfer can be utilised to train robots to perform tasks that would be difficult or impossible to train them to perform within the real world. ALPHASTAR mastering STARCRAFT 2. In 2019, Deepmind's ALPHASTAR made headlines by achieving Grandmaster level performance in the popular real-time strategy game STARCRAFT 2. This accomplishment was extraordinary, as STARCRAFT 2 is a highly complex and dynamic game with imperfect information, making it a significant challenge to AI systems. ALPHASTAR's success in this domain showed the ability of self-learning systems to adapt and excel in real-time, unpredictable environments. MuZero learning without a model. MuZero is a reinforcement learning algorithm developed by Deepmind that can learn to play a variety of games without being unequivocally modified to the rules of the game. MuZero does this by learning a model of the game state, and after that using this model to plan its next move. MuZero is a significant development over previous reinforcement learning algorithms, as it can learn to play games that are much more complex than those previous algorithms could learn. For instance, MuZero has been able to memorize to play Atari games, Go and chess, all without being expressively modified within the rules of the game. MuZero works by first learning a model of the game state. This could be a statistical representation of the game state, and it captures the likelihood of different outcomes given the current state of the game. MuZero at that point uses this model to plan its next move. It does this by considering all the conceivable moves that it may make, and after that assessing each move based on the probability of that move leading to a win. MuZero has appeared to be exceptionally successful at learning to play games. It has been able to realise superhuman performance on a variety of games, counting Atari games, Go and chess. Ethics and safety in AI. With the rapid advancements in self-learning, Deepmind also recognised the need for ethical considerations and safety measures. The lab has been actively involved in AI ethics research and has advocated for responsible AI development to avoid potential harmful consequences. The company incorporates a number of ethics and safety principles that direct its work. AI ought to be utilised for good. Deepmind believes that AI ought to be utilised to benefit humanity and not to hurt it. AI should be made explainable. Deepmind accepts that individuals should be able to understand how AI frameworks work, so that they can be held responsible for their actions. AI should be safe and reliable. Deepmind believes that AI frameworks should be designed to be safe and reliable, so that they don't pose a chance to people or the environment. AI ought to be inclusive. Deepmind believes that AI frameworks should be designed to be inclusive so that they advantage everybody, not just a select few. Google's AI lab, Deepmind, has undeniably progressed the field of self-learning to an exceptional level. From mastering complex board games to real-time strategy games and understanding complex real-world problems, Deepmind's contributions have reimagined what AI can accomplish. Thank you! For more videos like this, follow our channel. Make sure that you like, comment, share, and subscribe.